If you had asked me not that long ago if I had plans of buying a CNC machine, I would have said definitely no for sure. I just saw myself more in the manual hemisphere of the machining world than in the CNC one. But somehow things have changed in the latest past, and the wish grew inside me of having a small CNC lathe in the workshop for a specific job I have in mind. And before you ask, building my own machine was never an option. I'm just not in all the electronics and programming which is involved in such a project. And most important, I don't want to waste months of time and work and having a not properly working machine in the end. So I searched the internet for a machine which fits my needs regarding the size and the price. The market for small CNC machines is really not that big. In fact, it's almost non-existing. Here in Europe or in Germany, one company which comes into your mind when thinking of small CNC machines is Emco. Emco is an Austrian company which, till today, makes all sorts of both manual and computer-controlled machine tools. In the past, Emco not only made small and affordable manual machines for the hobbyist, but they also made some small CNC machines, mostly for educational purposes. The machines were meant for learning the basics of operating a computer-controlled machine during apprenticeship. I first looked for an Emco Compact 6 or Emco Turn 120, which are basically the same machines, but I got the advice that for the first steps in the CNC machining world, an Emco Compact 5 would be the ideal machine. So not that much later, I bought exactly this machine. The Emco Compact 5 CNC is a tiny benchtop CNC lathe from the 1980s. As said, the machine was mainly designed for education, and despite of its small size, it features the industry standard CNC controls and programming of that time. The Emco Compact 5 CNC was produced in 3 different versions, known as Mark I, Mark II and Mark III. The Mark III version is, for whatever reason, today better known as Mark IV. Each following version had a little bit more features and was a little bit more advanced in the programming. As you could upgrade the machines for newer versions, it's not that clear which machine you get when you buy one on the used market today. The machine I bought was originally an older version, but the pre-owner upgraded it to the Mark IV level and also added some additional features which had none of the original machines which left the Emco factory. But more to that later. As the purpose of this machine was to teach the machining apprentices how to operate a computer-controlled machine, there are a lot of manuals and educational documents which normally come with a machine. This should make starting with a machine relatively easy, even if you, like me, have no experience with CNC so far. However, the machine I finally bought had none of these manuals with it. In fact, it came with almost no accessories. Only an USB stick with digital documents, bad for me mostly in English, was given to me with the machine. The original yellow ring binder you see here is just borrowed from a friendly colleague, so I can make a copy for myself. So in this video I will give you an overview over my new machine, show you all of its features, tell you my plans for the future and show you what has to be done on the machine to make it work properly again. The Emco Compact 5 was also made in a non-CNC version, which is, from the mechanical side, almost identical to the Compact 5 CNC model. The only difference are the stepper motors on both axes, ball screws instead of trapezoidal ones, and a bed slide made out of cast iron instead of cast aluminium on the non-CNC version. And of course, the automatic tool turret, which not every of the Compact 5 CNC machines have, but mine luckily does. The machine itself is actually really tiny. The machine bed, which is from cast iron, is in fact only 55 mm wide, which is significantly smaller than the 85 mm bed width on my real Mini Lathe. However, with 350 mm width between centers, the Emco bed is actually 50 mm longer than the bed of my Mini Lathe. The lathe came with a pretty rusty but original chuck from Emco. Despite of the rust, that is a good thing because Emco decided to go for a really unique and weird spindle nose with a chuck mounted with 3 screws in the middle of the chuck. As far as I know, there are no third-party chucks for this mount available, and the original Emco chucks are, even used, extremely expensive. The chuck itself looks a bit weird and more like a drill chuck. However, it sits relatively close to the spindle stock and spindle bearings and has, due to its flat design, very little stick out, which should make the whole assembly relatively stiff. The lathe also came with, no surprise, a small tailstock, which is made, I guess, out of cast aluminium and feels pretty lightweight and flimsy. It has a quill travel of about 35 mm and takes Morse Taper 1 tooling. Luckily, one of the few accessories which came with my lathe was this small drill chuck from Röhm, which fits the tailstock pretty well. Both the X and the Y axis have a stepper motor mounted and are driven by 8 mm ball screws with 2.5 mm pitch. The 2 stepper motors have the breathtaking resolution of 72 steps per revolution, which is 5 degrees for each step. Together with the belt drive and the 2.5 mm pitch of the ball screws, this results in a movement of 1.38 hundredths of a millimeter per step. If you are asking now, why the hell it is 1.38 hundredths and not 1.39 or 1.37 or not just, hey, 1.0 hundredths of a millimeter per step? I just can't answer that. I guess that has to remain Emco's secret. As the display of the machine can only show full hundredths of a millimeter, Emco decided to do weird roundings. One step, which is, as said, an X or Z-axis movement of 1.38 hundredths of a millimeter, is displayed as 1 hundredths of a millimeter. 2 steps, which give a movement of 2.77 hundredths of a millimeter, are displayed as 3 hundredths of a millimeter, and so on and so forth. So, who needs the boring precision of Kernmikrotechnik if you can have the excitement of a lottery-like gasometer machine like this? But anyway, the last thing to discuss on the mechanical side is the automatic tool changer. The automatic tool changer has 6 positions and can take 3 normal turning tools, which are inserted in the slots, and 3 drills or boring tools, which are holed in 10 mm holes in the turret plate. For smaller drills, there are bushings, which I don't have, but they can easily be made by yourself. You have to be careful that the turning tools don't stick out too far, as they otherwise collide with the carriage. You can just read the maximum stick out from the manual, or you like the complicated way and clamp a piece of wood in one slot, rotate the turret 100 times, adjusting the wooden block, and finally have your number. In my case, with a piece of wood, I measured a maximum stick out of 14 mm. The manual, however, speaks of a maximum stick out of only 13 mm. I guess Emco went for a little higher safety factor here. And now, let's take a closer look on the CNC control panel, which is installed directly on the back of the machine. I really do like the style of these old school controls. On the left side, there is a chart printed on the control cabinet with all the main G-codes and programming commands. As this is the chart from an older, I guess Mark II version of the machine, some of the instructions are outdated on the upgraded Mark IV version. There was a new sticker which came with the Mark IV upgrade kit, but it is not updated here. The next cool thing which comes into sight is the key switch. I mean, how cool is that to have a machine which has to be started with a key? When you turn the key, the machine starts with a loud bang, I guess from a contactor, a nice beep from the monitor, and the soothing humming of the cooling fan. You immediately get the feeling of doing some serious stuff here. Left to the key switch, there is a knob which sets the language you talk to the machine. You can choose between the units millimeter and some weird INCH thing. Don't really know what that is, so better stay on the right side. Right to the key switch, there is a big emergency cutoff switch, and underneath there is the motor on-off switch with a potentiometer. Older versions of the machine had only a 2-position motor switch. Newer or upgraded models have a 3-position switch. In the upper position, which sets the motor control to manual mode, you can just turn on the motor manually with the speed set with a potentiometer. The speed can be set between 16 and 100%. In the lower on position, which sets the motor control in the CNC mode, the motor doesn't start immediately. The motor start has to be programmed in the CNC program, and the motor starts automatically when the program is run. From factory, the motor can only run with the speed you set on the potentiometer before starting the program. I don't know how exactly, but the previous owner changed the electronics so that the spindle speed can now be set and changed directly in the program using the M codes 22 and 26. With M22, you tell the machine to override the potentiometer, and with M26, you set the spindle speed to values between 15 and 100%. That is a really cool and unique feature this specific machine has. On the right side, there are the buttons for operating the machine in the manual mode, and the number block and buttons to operate the machine in the CNC mode and directly write your programs on the machine. The blue HC button switches the machine between the manual and the CNC mode. The green start button starts a written program when the machine is in the CNC mode. When you start the machine, it is always in the manual mode first. This is indicated by the green LED right to the hand symbol. So right now we are in the manual operation mode. You have 4 buttons for moving the X and the Z axis in both plus and minus direction. The speed with which the axes are moving can be set with a potentiometer above between 10 and 400 millimeters per minute. The blue button right to the potentiometer is for rapid traverse. When it is pressed in addition to an axis movement button, the crosslight or the carriage moves at its highest possible speed, which is, in the case of this machine, 700 millimeters per minute. The previous owner of the machine has already installed an additional display which shows both axis movements at the same time. In its original state, the machine can only display the travel of the active axis. Which axis is active is shown by the green LED above the display. On the additional monitor, it is indicated by the white background on the active axis. And now, let's take a closer look on the CNC operation mode of the machine. As said, the CNC mode is entered by pressing the blue HC button. When entering the CNC mode, the additional display shows CNC Betrieb, and you can enter your standard G codes into the machine. By pressing the input button, you go to the G column, in which you can type in the G code you want. In my case, just for demonstration purposes, I type in G84, which is a standard turning cycle. By pressing input again, you enter the X column, in which you set the X value of your cut. The numbers have to be typed in 1/100ths of a millimeter. So 150 means 1.5 millimeter total depth of cut. The minus sign sets the right direction for the cut. And now the same for the Z value. The F column sets the feed rate with which the cut is taken. It is measured in millimeters per minute. The H column finally sets the depth for each individual cut. 50 means 0.5 mm per cut, which gives a total of 3 cuts for the 1.5 mm of travel set under the X column. With this, the first line is complete, and pressing Enter automatically switches us to the second line. The forward or reverse buttons let you jump between the lines and allow you to run forward or backwards in your program. On this machine, you can type in programs up to a maximum length of 222 lines. This should be absolutely sufficient for most cases. I have already said that the previous owner of the machine has done some modification to the machine, mostly on the electrical and software side. One thing he has done is this additional control panel he installed right in the place where a cassette deck is installed in the original machine. I got the cassette deck along with the machine, and perhaps I will reinstall it later to bring the machine back into its original state. The cassettes were used to save and load programs written in the machine. Really old school for today's standard, but I kinda like it. On the added self-made control panel, there is an additional hand to CNC mode switch, an additional program start switch, and some buttons for new functions which were not directly available on the original machine. On the left side, there is a stop button which aborts a running program in case something goes wrong. Normally, you have to press the input and ref buttons at the same time for stopping a program. The yellow Zwischenhalt button means program hold and allows you to interrupt the program for doing measurements, for example. With pressing the start button again, the program continues where it was interrupted. That's also quite a bit more convenient than having to press the input and forward buttons at the same time as you have to on the machine in its original state. Underneath the stop button, there is a black button which says RS232. This button enters the data transfer mode for communicating with the computer via the integrated serial port. With this, you can load programs written on the computer onto your machine or vice versa. In addition to that, the pre-owner also improved the data transfer rate from 300 baud original up to 1200 baud or even 9600 baud, which can be set with a small 2-position switch. The 9600 baud seem to work not that reliable, but even the 1200 baud are so much faster than on the original machine. And last but not least, there is the red reset button, which is kinda self-explanatory, I guess. Now that we kinda know the machine, it is time for some bad surprises. The first thing I noticed was that the machine just doesn't want to cut threads. I typed in a threading cycle, but when I press the start button, only the motor starts, but the machine doesn't start to cut the threads. The program just remains in the threading cycle, and it wasn't even possible to abort the program with a stop button. I had to reset the machine to exit the failed program. After a little bit of fiddling around, I finally found out that one of the sensors for picking up the spindle speed was not mounted in its correct position. There are 2 sensors, one for counting the spindle speed and one for picking up the position of the spindle and giving the start signal for thread cutting. The latter was not in the correct position and just didn't give a start signal to the machine to start the thread cutting cycle. With adjusting the position of the sensor, this was relatively easy to fix, but at the same time, the next problem occurred. The G78 thread cutting cycle automatically cuts a thread, retracts the tool and brings it back to its start position for the next thread cutting pass. However, I noticed that the tool just doesn't move backwards to clear the threads before going back to its start position. That means that it damages the previous cut threads on its way back, which is, of course, not intentional. I installed a small dial indicator to verify my feelings, and sure enough, there is almost no retraction movement. The crosslight only moves in forward direction. After a little bit of thinking around, I came to the conclusion that this has to be the mysterious backlash everybody is talking about. I measured, with a dial indicator installed, how much steps I can move the crosslight until the needle on the dial indicator is moving. And to my surprise, it is more than 0.2 of a millimeter of dead movement, or backlash as it's called correctly. Of course, that's pretty terrible and unacceptable even for a small hobby lathe like this. To see what's wrong with the ball screw, I had to remove the stepper motor from the X-axis and partly disassemble the crosslight to get to the ball screw. This included the removal of the tool turret to reach the mounting screws underneath. The ball screw has a feature for adjusting the backlash, but while slowly turning it by hand, it felt also a little bit rough. It seems that sooner or later there has to be done some work to the old screw. Perhaps I will change the bearing balls inside, but that's a bigger thing and not for this video. While disassembling the crosslight, I also noticed that there is significant play in the lathe carriage. With a dial indicator, I measured a stunning 0.2 of a millimeter of movement here as well. That is the next thing I definitely have to fix. I also have plans for making some kind of a bedway protection for the machine before starting to do real work with it. The bedways are in pretty good shape as far as I can tell by eye, and I better do my best of preserving them in this state. Another thing I'm thinking about is to add a small additional control cabinet for the switches the pre-owner added and for the additional display, which is at the moment only mounted with sticky tape to the metal cover. So some things have to be done until I have a real functioning machine, but nonetheless, I'm still very happy with the new addition to my shop. It's really satisfying to see a machine doing its thing totally on its own. At least for the end of this video, I show you a tiny sequence of the machine working. Just a few simple cuts in plastic, but enough to show you the machine actually works. More has to come in the future. Thank you all for watching, thanks to all the Patreons supporting me, and till next.